Okay, so the chapter is force, density, and pressure. Uh, the new topic is torque, which is also called the moment. What is the concept of the torque? What is the meaning of the torque? What's the meaning of the moment or the turning effect is when force is applied on the object, an object rotates about a fixed point, then effect of force is called turning effect, moment, or torque. This is just the meaning, concept of the torque, not the definition. Look, if this is the rod and it is pivoted here, and this is the point P at which the force is exerted up. Now the distance of the force from the pivot is suppose D. So when force is applied, this object, this rod rotates about the fixed point, this C. So this is the turning effect. This is the torque. Now this torque depends on, number one, the magnitude of the force applied, means size of the force. Number two, it depends on the distance between force and pivot. And number three, it depends on the angle theta between distance and force. When the angle theta is 90 degree, the torque is maximum. When the angle theta is 0 or 180 degree, then the torque is minimum, mean it is 0. So for the perpendicular distance, the torque is maximum. That's why it is defined as product of force and its perpendicular distance from the pivot is called torque. This is the definition. So when we have to define the torque, moment, turning effect, it's a product of force and its perpendicular distance from the pivot. So torque is the product of force and distance. Now it is measured in Newton meter because force in Newton, distance in meter. So the unit of the torque is Newton meter, mean this is the SI unit. And the base units will be kilogram meter square second power minus 2. This is the base unit. Now, this formula is only valid when force and distance both are perpendicular to each other, mean they are at the angle of 90 degree with each other. But if the force is not perpendicular, like this. This is pivot, and the force is going in this direction. And this is the distance. And this angle is theta other than 90. So there is a torque, but F multiplied by D is not the formula for the torque. We will resolve this force into components. So this force, this component is Fx, and this component is Fy. So the forces is resolved into two components. One is Fx, other is Fy. Now, this Fx component is passing through the pivot. So do remember, force which is exerted at the pivot or passing through the pivot has no torque, no turning effect, no moment, because its perpendicular distance is 0. So this Fx has no torque. Now look at this Fy. This Fy is making 90-degree angle. So in this case, the turning effect, the torque is Fy into D. If the force is not perpendicular, resolve the force into components. One component Fx will pass through the pivot, so it has no torque. One remaining Fy, which is perpendicular to distance, so the formula will be Fy into D. So further, Fy can be written as F sine theta into D. So we can write Fd sine theta. This is the torque. So when force and distance both are perpendicular to each other, the formula is just Fd. If force and distance not perpendicular to each other, then the formula is Fd sine theta. Now, d sine theta is the perpendicular distance. So when you will draw a perpendicular from the pivot to the force, this is actually the perpendicular distance, and this is d sine theta. If the question is, draw the perpendicular distance between force and pivot, so this dotted line is the perpendicular distance, mean this is d sine theta. Look, this is d. This is a right angle triangle. This theta is the angle. So this opposite side is perpendicular, and side this D is the hypotenuse. So perpendicular over hypotenuse sine theta. So we can write perpendicular over hypotenuse is equal to sine theta, mean this perpendicular is equal to hypotenuse is d sine theta. So the perpendicular distance is d sine theta, mean we have to multiply perpendicular distance by all means with the force. Now, there are two types of the turning effect. One is the clockwise, and other is anti-clockwise. Like, suppose we have a disc, we have a wheel, it is pivoted somewhere here at this position. This side distance, suppose d1, this side distance, suppose d2. Now one force is acting in this direction, which is F, other force acting in this direction, which is also F. Now both forces are trying to rotate in the same direction clockwise. But when we have another disk, one force is in this direction, other force in this direction, both forces are trying to rotate in this direction, which is anti-clockwise. So there are two types of the turning effect, moment torque, clockwise, anti-clockwise. Now in this example, especially in this example, look, both forces are equal in magnitude. Number two, both forces are opposite in direction. Number three, both forces are parallel to each other. And number four, both forces are rotating in the same direction clockwise. So both are rotating the object in same direction. So look, these are the four properties between these two forces. They are equal in magnitude, they are opposite in direction, they are parallel to each other, they are rotating the object in same direction. If these four conditions are fulfilled, then the forces are called couple forces. If one of the property is missing, then they are not couple forces. They must be equal in magnitude. They must be opposite in direction. They must be parallel to each other. They must rotate in one direction. Then they will be called couple forces. So these are the four properties required for the couple of the forces. Now, this force has turning effect FD1. This force has turning effect FD2. So the total torque is FD1, FD2. So look, F common, D1 plus D2, and this is the torque due to the couple forces. That's why it is also called couple torque. And the formula F D1 plus D2. Now, if the question is, what's the definition of the couple torque? Look, we are using just one force. And what is D1 plus D2? It is the total distance between the two forces, not from the pivot, total distance, but it is perpendicular. So we will define as this couple torque. It is the product of one of the force from the couple, look, this one force, and total perpendicular distance between two forces. So this is the definition. Just one force from the couple, but total perpendicular distance between two forces. This is the definition of the couple torque. Okay, now equilibrium. It is the state of the object in which object has zero acceleration. If the acceleration in the object is zero, then the state of the object is equilibrium. Yes, according to O level. When the object is at rest, yes, it has equilibrium. When it's moving with a uniform velocity, it has equilibrium. But in A level, the first condition which we have to write in the exam paper, number one condition is vector sum, mean resultant of all forces acting on the object must be zero. vector sum of the all forces acting on the object must be zero. Mean the forces which are acting on the object, if added according to head to tail rule, the resultant of the forces must be zero. For example, this is the pendulum which is displaced one side. It is held stationary. Three forces are acting. One is the weight, other is the tension, and the third is your force to hold it. So it is at rest, so stationary. So when we will add these three forces according to head to tail rule, this is the vector weight, this is your force F, and this is the tension in the string. Look, it's a closed triangle. So the force resultant is zero. So the first condition is fulfilled. The object is in the equilibrium because the forces sum, the vector sum of the all forces is zero. And the second condition is sum of clockwise moments must be equal to sum of anti-clockwise moments. Mean the resultant torque must be zero. Like if this object is balanced exactly at the pivot, one force is hanging here, this is W1, and the other force is hanging here, this is W2. So this force is acting down, this force is acting down, this is trying to rotate in the clockwise direction about this pivot. This is trying to rotate in this direction. If it is in equilibrium, stable, then the clockwise moment produced by W2 must be equal to the anti-clockwise moment produced by W1, which is also called principle of moment. And what's the definition of the principle of moment? In the state of equilibrium, sum of clockwise moments must be equal to sum of anti-clockwise moments. So for the equilibrium, there are the two conditions. The first is the vector sum of the forces must be zero. And the second, the resultant torque must be zero, which is also called the principle of moment. Like this. This is the rod. One force acting in this direction, downward. Suppose this is F1. Other force acting in this direction. This is F2. Now this distance is D1. This distance D2. So if the object is in the equilibrium, then we can write F1 D1 is equal to F2 D2. If this force is large, for example, 6 Newton, and this distance suppose 2 meter, so their turning effect is 12 Newton meter. If this force is just 4 Newton, then this distance will be 3 meter to get the same 12 Newton meter for the equilibrium. So look, in the state of the equilibrium, when force is large, distance is small. When the force is small, distance is large. So in the state of equilibrium, F and D both are inversely proportional to each other. Larger the force, smaller the distance, smaller the force, greater the distance. So we can draw the graph between force and distance for the equilibrium. This is distance, this is force, both are inversely proportional. This is the case when the object is in equilibrium. And number two, this force F1, this force F2, both are parallel to each other. So here is a third force which is acting up, which is the reaction of the pivot. When forces are parallel, equilibrium, then sum of upward forces must be equal to sum of downward forces. Mean this is 6 Newton, this is 4 Newton, so this must be 10 Newton to balance this. So in the state of the equilibrium, if the forces are parallel to each other, then the sum of upward forces must be equal to sum of downward forces. This is the only case when the forces are parallel, right? So this is 6, this is 4. So this pivot is exerting how much force? 10 Newton. Now it has clockwise turning effect. It has anti-clockwise turning effect, but the R has no turning effect. Reason, it is exerted at the pivot.